we have a graph y equals 8 divided by x, and this is a hyperbola, right? Or we can even graph it. We can graph 8 divided by x, is not a problem, right? So let's plot also 3, 0. This is 3, 0. And we know how to graph 1 over x. We've graphed 1 over x so many times already. Forget about the 8. Just forget about 8 for a second. How do I graph 1 over x? Right? Yeah. 1 over x. We graphed it many times, right? Okay. 8 over x is very similar. And I don't need the other side, but let's graph both sides. So this is y equals 8 over x. We're asked to find the point on the hyperbola x, y equals x, or y equals 8 over x, the same thing. Function 8, y equals x over x, that is closest to the point 3, 0. So what are we trying to determine? Yes, we're trying to determine the minimum what? Excellent. Yes, minimum distance. Minimum distance. Yeah, this will be the minimum distance, right? I'm going to say this is whatever point, general point. Can anyone give us the coordinates of point A? Coordinates of point B, 3, 0, coordinates of point A. You don't have x, but you know y will be, which is? Indeed, thank you very much. So we are trying to determine the distance between A and B and minimize it. So how do I write the distance AB? Excellent. What is the formula for the distance between 2 points? The square root of x2 minus x1 squared plus y2 minus y1 squared. All I have to do now is label. I will consider point A, x1, y1. I will consider point B, x2, y2. All I have to do is just plug it in. So x2, 3 minus x squared plus y2, 0 minus 8 over x squared. I'm far from being done, but this is the function. And now I can call it d of x. This is indeed d of x, the square root of. I don't really have to simplify it, but I'm simplifying it a little bit. Okay, so if we go through the steps, we read the problem carefully. We drew a picture where we came up with the information that we are given, and also we know what we are asked. We determined the function, and now we are minimizing it. What do I have to find first? Very good. Can anyone dictate? Times what?
Times negative 2x.
Bring 2 in front. 3 minus x times the inner function prime. Very good. Times negative 1. And then let's copy. Yes, it is. So let's copy 64 times x to negative 2. Bless you. So this is times negative 128 times x to negative 3. So 64 times x to negative 2, bring down negative 2, negative 128 times x to negative 3. Yes, I know it kind of looks awful. Yes, right?
I don't understand how you got the numerator when it should be 1 over d of x times.
It's 1 over 2, the square root.
Of d of x.
No. Okay, So I have the square root of a function prime. 1 over 2 the square root of the function times the function prime. So here's the function. This is the function. So when I differentiate 3 minus x squared plus 64 over x squared, I differentiate the function squared, 2 times 3 minus x to 2 minus 1 times the inner function prime.
I thought it was under a square root.
No, not at the top. This is not under the square root. We're talking about this. 2 is here, the square root is here. We're talking about this. This is up here. This is in the numerator, not in the denominator. And then minus 128 over x cubed. Is that clear now?
No, I thought the function was under the square root.
Yes, the function is under the square root. Look at it. But this is the derivative that I already put at the top. You either put it here with parentheses or you put it directly at the top because it's over 1.
So wouldn't it be 1 over 2 square root of the function times the inner function prime?
So, one more time. You understand that this is the function, correct?
Yes.
Good. So I have to write 1 over 2 the square root of the function. This piece is 3 minus x squared plus 64 over x squared prime. Not with a square root, not 1 over, nothing. And when I differentiate this, I get 2, 3 minus x times the inner function prime, and then minus 128 x cubed, x to negative 3. Is that better? Perfect. So this piece, I can write it over 1, or because I always run out of room, you know me, I already put it at the top. Is that better? Okay, perfect. Good. I would like to continue. Then what do we do next? We have the derivative. What are we trying to do? Yes. So we have d prime equals 0. So just the numerator will be 0. So I'm going to try and simplify this a little bit. So I'm multiplying by negative 2. So this is 2x minus 6. So negative 2 times negative x and negative 2 times 3. And then minus 128 over x cubed equals 0. Okay, I have to find the least common denominator. Let's see what happens next. So 2x to the 4th minus 6x cubed minus 128 divided by x cubed equals 0. So then 2x to the 4th minus 6x cubed minus 128 equals 0. Of course, I'll divide by 2. Get x to the 4th minus 3x cubed minus 64 equals 0. And now I'm stuck. Why am I stuck? It's because I don't know how to solve any polynomial equation that, yes.
What did you do to get that first equation?
I found the least common denominator, which is x cubed. I multiplied this by x cubed to get this.
Oh, okay.
I multiplied this by x cubed to get this, and then minus 128.
Okay.
And then I set the numerator equal to 0, and I divided both sides by 2. So why I got stuck is because I don't know how to solve this by hand, but I have Newton's method. And I can get the solutions no matter what to save some time. My calculator broke. That 86 that I was telling you about, it's not working anymore. Why? I don't know. I replaced the battery, replaced even the backup battery. It's absolutely dead. So what we can do is go and try to find the solutions of this. A lot of talking in the back. So next time I'm going to have to rearrange you. So if you want to have the right to sit in the back, I don't want to hear anything coming out of there. Otherwise, You're going to be moved like in second grade. I don't want to do that. This is the last warning. Thank you. Minus 3x cubed. And minus 64. Okay, so now let's see if we can get this with,
You put in x cubed, not 3x cubed.
aw,
3x.
I did. Second, okay, and 3. Good. So now when I go to second and calc, I have a cheat sheet here in the software, but I'm trying to find the zeros of this. But the viewing window is not good enough to give me, I expect 4 zeros or only 2. So I really want to see this function better. I don't know where it's going up, or I know it's going up because it's degree 4 and positive leading coefficient. So I'm going to change the y minimum to negative 50. See what happens with a scale of 5. Okay, not good enough. I still don't see everything, but it appears that it has only 2 real solutions. But I still want to convince myself that that's the case. So I'm going to go to negative 100. Let's see what happens now. It should turn somewhere here. Yeah, okay, good. So it has, as you see, an inflection point from opening up and opening down. It has a minimum. So obviously this is very clear. It has 2 real solutions. One appears to be 1, 2, 3, 4, and the other one somewhere between negative 3 and negative 2. So let's take a shot at that. So second and calc, and now I can determine the zeros. And between negative 3 and, yes, and negative 2, that will be one solution. Yes, Ricky? Yes. Yeah, I went to a negative 100 because I wanted to see the function, but the y maximum 10 is good enough, and the scale is 10. So then if you don't,
I think so.
yeah, you can do that. See, but you already have it. You have it perfectly now. Okay, so I need that solution. So I don't want to guess, and I get negative 2.29, negative 2.2, or we do Newton's method. And the other one, I think it's 4, but I don't want to guess. So second and calc, and I want another 0. So I'm going to say between 3 and 5. 3, enter, 5, enter, and no guess. Yes, it is 4. And x equals 4. After all this work, I got the 2 solutions, critical numbers. So then we have x, and then we have d prime, and then we have d of x, and we have negative infinity to infinity, negative 2.29, 4, 0, 0. Now, I cannot disregard anything. I have to go back to the derivative. I will not plug in anything here because it's the square root and it has to be positive. So I will only worry about this quantity, actually. But now I have to worry about this because it's x squared times x. I cannot cross it out and say I don't worry about it. I do have to worry about x. So I have to plug in some values. Let's plug in 0. I can plug in 0. 0 is undefined. So we can use 0. We can use 0 for the top, but not for the bottom. So 0 is not an option. So let's put this function in and find the sign. So I'm putting it in because it's easier to plug in numbers. So the function is 2, parentheses for the top, 2x to the 4th, and minus 6x cubed. and minus 128. Close the parenthesis, and I divide by x cubed. And now I plug in numbers to find the signs. So I'm going to plug in a number left of negative 2.29, like negative 4. A number between negative 2.29 and 4, like 1. And a number beyond 4, like 10. So here are the signs that I got. To the left of negative 2.29, I got negative. Between negative 2.29 and 4, I also got negative. And from 4 to infinity, I got positive. So one more time, find the point on the hyperbola that is closest to the point 3, 0. Does this mean anything? No, because the derivative doesn't change sign. Does this mean a minimum or a maximum? Minimum, because the negative sign, 0 and positive. Excellent. So the minimum distance appears to be when x is 4. Now, we're asked, I think they're asking us to find the point. So if x is 4, they also are asking for the y coordinate. So x is 4, so we have to determine d of 4. Now, who knows where d is? Okay, here it is. I found d. The square root of 3 minus 4 squared plus 64 over 16. That would be d of 4. So this will be 1. And here I have 3. Nice. So the square root of 4 is 2. So the point that is the closest to y equals 8 over x is the point 4, 2. From 3, 0. From 3, 0 is 4, 2. Let's summarize what this test is going to cover. And you tell me what you would like. We have 15 minutes, and I would like to use them. Any questions for me? Any questions? Okay. So number 1, max min on a closed interval. Exactly what you had on the previous quiz. Topic number 2, roll and mean value theorem. Rolle's theorem and the mean value theorem. Number 3, graph a function with everything. First derivative, critical numbers, increasing, decreasing, everything. Number 4, a max-min problem. Number 5, L'Hopital's rule. Number 6, Newton's method. There is nothing else. This is it. I would like, if possible, not to review for 2 hours, but I would be more than happy to do it if we need to next time. I would have loved this test to be next Saturday and the whole week or whatever, the following week. We'll see. I don't think we can. I can't next Saturday, though. Okay, so what would you like us in the next 15 minutes to work on? You choose, we'll do it. Graphing, very good. Let's choose a function. Remember, these functions can be very involving. Okay, what about problem 22 on page 352? We are given a function which is y equals x divided by 1 minus x squared. If we did this problem, I will choose another. Do you remember if we did this problem? Would you like one with a square root? You like one with a log? Or you prefer this one?
This is fine.
Is this okay?
Yeah.
Perfect. Good. How do I start?
Maybe
What is my first concern?
domain.
Excellent. Very good. So I will rearrange it because I want everything in descending order. I will factor the denominator. And then I will get the table going. Remember to use and summarize the information in any way you want, but it has to be summarized somehow. You choose how. But please don't make me look at